Mercedes.
I am Mercedes from Spanish Foundation SETMAR, and I would like to welcome all of you once again to our PrimeFish webinar, and thank you for your interest. As most of you have already participated in some of our webinars, just to quickly remind you that we are overviewing today some of the results of the PrimeFish project. We will be focusing on the growth risk analyzer, one of the features of the software tool that is being developed by the project. And we have more dates to come. During this month of October, we are focusing on the tools, and then in November, we will have a series of webinars focused on the markets that we have studied, maybe Spain, Italy, Germany, France, and United Kingdom, and we will be holding these webinars on the language of each country. We will finish this program with one webinar focused on sustainability on the seafood sector on December. So you are very much welcome to join us in these dates and follow your interest on the project. And as in previous webinars, we have this right window on your screen open for the chat, so you can send us every question that you may have during the webinar. So we will be having with us today Marco Viani, one of the main authors of this research from the University of Parma. And later we will have the show-how by developer George of Syntesa. This is all from my side from the moment, so I give the floor to Marco.
Okay, I'm uploading the document. Welcome to everyone to this webinar. Now you should see it in 2 or 3 seconds. Let us see.
Yes, perfect.
Okay. Can you see? Okay. This is a joint work with all the group of the University of Parma. And as you know, the involvement of our group concerns mainly the prediction of monthly fish prices in the next 12 months and the detection of potential boom and bust. Okay, this was mainly our involvement. So the challenge was to create a prediction model which was computationally fast, easy to read, and very important, which is understandable for fish market operators. So we have to think that we are not dealing with expert statisticians, but we are dealing with persons who see statistics once, in a while. Therefore, what are the characteristics of the time series that we are dealing about? They are very short. They do contain outliers. These outliers can not only be sparse, but they can appear in stretch. Then there are missing values, and then the technique about missing values is to replace them with the last available value. At beginnings, we started working using the Kalman filter methodology. So that was initially gave good results, and you can see the output here in the screen of the Kalman filtering. Well, this is the usual decomposition of the time series in terms of trend. Then there is a seasonal component, then there is a cycle, and then there is the irregular. Well, for example, you see here that the seasonal is more or less as expected. On the other end, you see that the cycle, well, this is something that is hard to interpret from a statistician point of view. That you see that the cycle indeed is very, it has a sort of characteristics of the irregular components. Therefore, this led us to abandon this approach, because this approach is just for statisticians with a strong expertise. And the parameters here that you estimate, the parameter here that you estimate are variances. Or, for example, you see that the cycle is about 7 months. For example, for this data, it was hard to think that was a real cycle in 7 months. was very hard to interpret. Therefore, we moved to the Kalman filter approach, and then in this slide we show how the boom and bust are defined. But we, due to the Kalman filter limits, that the results can only be interpreted by persons who know a lot about statistics. Then this machinery was time consuming. An additional point is that this approach is not robust at all to the presence of outliers. Therefore, we have developed this robust machinery, which is called LTSDS. LTS stands for least trimmed of squares. So instead of minimizing the sum of squares of the residuals, you minimize a trimmed sum of the squares of the residuals. And this is the output on the left, the output that you had using the Kalman filtering. On the right, the output that you have using the new approach. You can see here, for example, there was a set of outliers. On the previous approach, this set of outliers were affecting the level of the trend. Now, our estimate of the trend is not affected anymore. And now you can see the residuals and the outliers around this period. Therefore, this approach is also valid when the time series is very small, can not only detect outliers, but it can also detect level shift and structural changes. And of course, seasonal pattern with a time varying seasonal component. And then this was precisely what I was mentioning you before, that is this approach is not affected by the presence of outliers. Now, let us go to the forecast, and this is the table of the forecast values. This is the forecast of the price. Then you have a lower bound and an upper bound for the next year. And then, okay, we check the validity of the forecast, and you can see, for example, that in this case, all the predicted prices are within the bands, which is an indication that indeed, at least for this time series, actually the fitting process is fine. Now, boom and bust. Boom and bust, are defined, of course, in terms of observation above or below the fitted trend line for a number of consecutive months. Of course, it is crucial to define this K parameter, this integer. This integer, which has been set to 3 months, but this is still something that can be subject of discussion. So you can see when your prediction lie below or above the fitted trend for a certain consecutive months. Well, everything here is based on a paper which has just been published on econometrics and statistics, which is a leading peer-reviewed journal, and is implemented inside the FSDA toolbox. And inside the FSDA toolbox, everything is fully commented. The FSDA toolbox comes from a joint project with the Research Center of the European Commission, and now we are talking from the Joint Research Center of the European Commission, because Gianluca is next to me. You hear just me talking, but he's next to me, and we are in the Research Center of the European Commission to constantly develop these toolbox. And then you can have more details about this function at the web address, which is shown in this web page. Therefore, coming to the conclusions, given that we had just 10 minutes, LTS combines components of the time series in a framework which can be easily understood, and in addition to that, it is robust. Therefore, you can have a level shift, you can have outliers, consecutive outliers, and you can cope with them. And the predictions are robust, therefore, to the presence of a typical observation. Now, the floor back to you, Mercedes. Thank you very much.
Thank you very much, Marco. So George from Syntesa will now show us a very practical show-how of how this tool works in the Prime software.
Thank you very much, Mercedes. Hello, everybody. I'm George from Synthesa, the developer of the Prime DSS toolbox. I'll be demonstrating for you in a second our implementation of this regression algorithm that Marco just demonstrated in his presentation. So I guess you guys can see my screen now.
Yes.
Great, fantastic. So I'm going to switch to the DSS, and as usual, I'm going to start just quickly introducing the tool for those of you who are not aware. The Prime DSS tool is composed by two frameworks. The main DSS framework, which contains the tools, and the wiki, which is a support wiki constructed on top of a wiki framework to provide information about the different tools and where you can find more about the different researches. I would like to reiterate again that this is a prototype. We are still working on updates and adding more data, but the tools are already functional and you can register and test them to yourself and see the different results that we're going to demonstrate. If you are not registered, if you go to the dss.primefish.eu homepage, you will see this page that I'm showing you now. And you can see at the top right corner, there's a register button or a register link that you can click, and it will take you to a registration page where you can fill the information and register yourself. It's quite a simple process. As this is a prototype, there is no necessity for confirmations or links. Once you register, you should be able to log in, as I will do now. So I'll just log in with my information here. And once you log in, you're going to be redirected to the home page of the DSS, where you can find quick access links to all of the tools, the latest tweets by PrimeFish project and their partners, and also a link to the wiki and to the main website of the project with more information about the project. Once you are in the homepage, you can click the Growth Risk Analyzer Quick Access link or the link in the top bar, and this will redirect you to our tool implementation. We are still working on some updates, of course, for this tool, especially in regards to usability, but the demonstration that I'm going to show you is going to be possible for you to try it out as well with the time series. So as Marco explained, this algorithm processes and creates a forecast for any types of values for a time series, as long as it's a time series and the values are connected to each other by a constant separation of time. Our implementation requires you to give us at least 24 values as an input. You cannot run the tool if you run less than 24 values. So otherwise, the implementation cannot guarantee its accuracy. And of course, also the longer the time span after the forecast, the less accurate is the prediction. So there are two forms that you can use this tool. One is through bulk data upload or manual data upload. Through the bulk data upload, you can choose a CSV file with the values and upload it to calculate the forecast, or in the manual, you can enter the values yourself. The format for the manual input is value after each value, separated by a semicolon. So 15, for example, and then you put the next one and then semicolon, and so on and so forth. If you try to calculate with less than 24 values, you're going to see an error message. And also, if you enter a value that is not accepted, like a string or a wrong value, you're also going to have an error message for that. For the data, for the bulk data upload, I'm going to quickly show you the format of the values that we need to use. I just need to find the file here. I apologize for that. I had it with me, but I just forgot where I put it. I apologize for that. second, please. While I locate and ready the file, I'm going to show you the manual data upload. I have some values prepared here. So if I input this time series here, it's just a bunch of values that I extracted. They simulate the number of flights throughout a period of time. And you click the calculate the forecast from values, you're going to see that you're going to be redirected to the results page. So once the data is processed, you're going to see the input values on that you just provided to the screen, and they're basically their order, the order that they were inputted. And you can see the first result graph here. This, of course, is going to show the original values, the blue line. They connected by the blue lines representing the values that you inputted. And also it shows the fitted trend line for this time series. So you can see here below how the trend is behaving. Followed by that, you will have a graph that shows the robust LTS residual. So you can see which points fit outside are outside the fitted trend line. And finally, you will have the original values with the original fitted trend line. And after the red line here, you will have two confidences bands, and in blue, the prediction or the forecast for the values you entered. You can hover to a point to check its value. We're still improving the labels here, but you can see that the X here is 164 for this value. So it shows the values you inputted and then the fitted trend line. I'm going to return now, and let me just get this file for you. Just 1 second. To open this and show you the structure of the CSV file. It's very simple for you to enter the bulk data. You can just input each value in a single line in the first line of an Excel spreadsheet, and then just save as and choose the type as CSV. I'm not going to demonstrate here because I realize now that my office is in Portuguese, so probably will not understand, but I already have the file there, so just choose it from my downloads. And once I upload the file, if everything is all right, you're going to see that no error messages are displayed, and you can just click to upload and calculate. And on that file, I just we just had some also random values, and you can see again the original fitted trend line, the original line, and the fitted trend line. And here in the residuals, you can see the points that fit outside of the curve. And finally, you can see the prediction and the forecast. So you have your original values in black, and then you have the fitted trend line and your prediction for the following months. And that's my demonstration. So I hope you enjoyed, and I'm open to any questions if you have about the implementation, and I give the floor back to Mercedes. Thank you very much.
Thank you very much, George. I remind all participants that you can send us your questions or participate, as we are not so many today. And in the meantime, we have one question here that asks us if it's possible to include additional variables to the price model, for instance, production volume, inflation, prices in other regions.
Yes, it is certainly, this is Marco. It is certainly possible to include them as explanatory variables. So you can test whether these explanatory variables then are significant or not in explaining your time series.
Mm-hmm. Thank you very much, Marco. And I will add, have you any tip for a company or for a stakeholder in the seafood sector to interpret these results?
I didn't get the question. My connection was a little bit bad. Can you please repeat, Mercedes?
Oh, yes, sorry, George. Have you any tip for a company or a user of the tool to do the interpretation of the results of the tool?
Okay, I didn't get just the first part now. Something about the users of the tool being able to interpret the results.
Have you any kind of tip or hint or any advice you'd like to share with them?
The interpretation of the result graphs should be pretty simple. In the results you will have, as I demonstrated in the last graph, in the last charts, after the red line, the forecast of the results. The first two graphs or the first two charts are maybe a little bit make a little bit more sense for someone who's used to statistics. So our idea is to implement as well in the wiki support. We're working on a new page that is going to help explain a little bit better to the people who are not well versed in statistics and might have some trouble interpreting the other graphs. There should be an update soon for that as well.
Those are great news. Thank you very much.
No problem. Yeah.
So we would like to remind all participants that they will receive a copy of the presentations in their mailbox. And as George has very well explained through his presentation, we are open to receive any feedback or suggestions or questions that you might have on the tool. So I would like to thank you very much of lecturers that have participated today and all attendants. Thank you very much.
Thank you.
Thank you very much. Have a great day, everybody.
Bye-bye.
Bye-bye.